Backyard Brains video lab, we bring you our newest exciting preparation, the rubber roach. To get started, you want to learn how to build your own electrodes. If you purchased a rubber roach kit from us, we included a few segments. To do that, I've sped up the sanding process in the interest of time. To interface with the cockroach nervous system, we use very fine silver wire from AM Systems. This is 0.003 inches in diameter, and you want to cut 3 separate pieces of each approximately being 1 to 1 1/4 inches in length. Using a lighter, now burn off approximately 1/8 inch of the Teflon insulation off the silver wire segments you just made. This requires a bit of finesse, as if you hold the wire too close you can actually melt the silver. Do this for both ends of each wire segment you cut. Now to solder the fine silver wire to the connector, we use a standard Radio Shack product with 2% silver in it. We make the silver wire into a loop, and we lay all 3 across the 3 connector segments. Now grab your favorite soldering iron and solder the 3 wires to the 3 connectors. Make sure each connection is distinct and that there are no shorts. And voila! You've now made your electrode. Now it's time for the biology. Take your colony of cockroaches, grab your largest discoid, and put him in the ice water. The ice water serves as the anesthetic. After a few minutes, he will stop moving and will be ready for the next step. Now, the reason cockroaches are such experts at getting into very, very small places is that their whole body is covered with a very slippery wax, which is very, very difficult to glue to. Thus, we're going to sand a little bit of this wax off of his pronotum. Now we're going to glue the connector. The superglue we enjoy is the Loctite Superglue Control Gel. It's not as runny as normal cyanoacrylate and very, very easy to control. Glue a little bit on his pronotum. Now, carefully place the connector onto the cockroach, with the solder points pointing towards the anterior end. The connection will be strong enough within 1 to 2 minutes. Now for the hardest step of this surgery, I have not figured out an easier way to do this. You need to put your ground wire into the thorax of the cockroach. Carefully splay one of his wings and secure it with silly putty. Now wipe off the excess water from the ice water anesthesia off his thorax with a Q-tip. Now again, since we're at a glue step, we're going to lightly sand the waxy coating of the thorax with a small bit of sandpaper. And with our Q-tip, we're going to again soak up the excess moisture from the ice water anesthesia. Now with a small needle, you can buy these at the drugstore, you want to lightly poke the exoskeleton of his thorax. Now very carefully place the lefternmost wire, park it in the small hole you just made in the thorax. This is a very, very hard step to do, as the wire will easily crumple on itself. You may find this takes multiple attempts to get it parked. Now, with a splinter of wood, take a small piece of superglue and place it on the wire just above where it goes into the thorax. You may find using a magnifying glass helps you. While I was shooting this video, it was easier for me not to use it. So I've put just a little bit of glue right above where it's parked, and then with my forceps, I'm carefully lowering the wire about 1 to 3 millimeters below the surface, so that it's in contact with the saline of the body. I put a little bit more super glue on top of where I just inserted it, remove the silly putty, and fold the wing back over to its natural position. Now is a good time to put the cockroach back in ice water anesthesia for a couple minutes. Now it's time to insert the antenna stimulating wires. Using your forceps, splay the antenna out, and then, with your scissors, cut the antenna down to with only 1/8 to 1/4 inch left. The antenna are hollow, fluid-filled structures with a nerve running down the center. Now you're going to position the middlemost wire to go into the cockroach left side. Park it just into the antenna. Don't put it all the way in. Now, as you did before, apply a little bit of super glue to the wire just above where you parked it. And then using your forceps, put the wire approximately 2 to 4 millimeters into the antenna. The point is to get the super glue just inside the inner ring of the antenna so it sticks on the inside. Otherwise it will slip out very easily. Put some more super glue around the antenna wire interface, and now put the cockroach back in the ice anesthesia. After a couple minutes, then repeat for the remaining antenna and the remaining wire. Easily glue to you instead of the back in the ice water anesthesia, and wait a couple minutes. Carefully fold back all the wires until they're in a nice loop on top of the connector, and potentially pull the wires out. This is a principal failure point. Now to hold the excess wire onto the hot glue. The baking soda prevents the hot glue. If I have a spiker box, I can actually try to record the neural responses in the antenna. That tells me the surgery was successful. I've plugged in my little adapter into the connector. I'll then plug in my micro clips, one to the ground and one to the left antenna, and turn the spiker box on. It sounds a bit noisy, so I'm going to turn off all the fluorescent lights to reduce line interference. That semi-random popping you're hearing is the spiking, or action potentials, of the living neurons in the antenna. I'll try the other side and check as well. The other side sounds good as well. Great neural response. Now it's time for the cockroach to recover. I'll simply put him in his cockroach house and wait, usually overnight. However, if I'm teaching in a classroom, the cockroach in a tub on top of the warm water, and it'll recover within maybe half an hour. Now to test your Roboroach. Take your Roboroach circuit and turn it on by pushing the switch all the way to the right. Make sure your transmitter's on the B channel and press the L and R buttons. On either side, it's time to plug in the cockroach. Notice that nice wing flapping behavior when I pick him up by the connector. That's a fairly stereotyped behavior that students like to observe to wonder about the mechanics of wing flapping. Now that he's on the table, simply plug in the connector gently. But how do we get it to stay on the cockroach? Take your hot glue again and put a small dab on the underside. It's not too hot. Don't worry, the cockroach is fine. How long do the behaviors last? Does he always turn left and right upon stimulation? Does the cockroach appear to show any sort of learning or adaptation upon repeated stimulation? Are you competing with any other sorts of behaviors? There are many types of questions you can ask about stimulation and neural responses with this simple prep. You're done with your experiment, it's time for the cockroach to go back into his house to eat and rest. Put him in the refrigerator to slow him down a bit, and then with your forceps, carefully ease the connector and put the cockroach back in its house. Sorry for that unsightly scar on my hand. I was changing the oil in my Tercel last weekend. Busted knuckles. Now you can start asking independent questions of your own. For example, from your neural engineering class, are biphasic pulses better than direct voltage? Here I've designed a Roboroach where I'm solely providing positive 3 volts to the antenna, and you can notice there's very little effect on the cockroach turning. This tells us that pulses designed to mimic action potentials are actually more effective. Now here's a confusing result. We have a different species of cockroach, the giant South American fuchsia cockroach, and when you stimulate his left and right antenna, he simply stops. It's more of a break. Why is this? Is there a behavioral reason? Or a stimulation reason? And eventually, the cockroach just ignores it and keeps walking upon stimulation. We're still trying to figure this out. Good luck on your surgeries. You can purchase a Roboroach prototyping kit on our website, backyardbrains.com. We'd love to hear your
Adam, what's in the box?
The box, so let me talk about this box for a second. I pre-ordered this incredible thing a few months ago. Totally forgot that I'd pre-ordered it until it arrived in the mail a couple of weeks ago.
That's the best experience.
It is totally the best experience. And this object that is in this box exceeded all of my expectations for coolness. Like what I saw in the videos and the promise of it, and what caused me to spend a lot of money to pre-order it, and it's even more now that it's past pre-order stage. It exceeded all my expectations, and it was very exciting. So I played around with it for a few days. I was finding that it's so delicate that I needed a way to cart it around. So I built this box. And
it's gorgeous.
I built it. This is. I've gotten good enough, man, that this actually took me about 3.5 hours from start to finish.
It's only a half-day build.
It was crazy how it went all together. But this is my delivery device for what is, I guess we should call, the Robugtix Spider.
Robugtix.
Robugtix.
T8X Spider.
Dun dun.
That is terrifying.
So, yeah, my director on Mythbusters was like, I will step on that. I will kill it with fire or a shovel. Don't bring it anywhere near me.
Let's give people a little backstory of what this is and who makes it.
Okay, so this is made by a Hong Kong company called Robugtix, and it is a platform using 26 super micro high-tech servos, 3 in each leg and 2 in the back tail here, and a controller that has pre-programmed a whole bunch in terms of distributing its forward motion across its legs.
So their big technology is the controller board and the algorithms to coordinate all the leg movements.
Yes, but the algorithms that control the leg movements are not just walk forward, walk backwards, turn left, turn right. It's actually far more advanced than that, and it's from an animating standpoint, like having been a puppeteer and having built animatronic puppets, this thing blows everything I've ever seen out of the water.
And that's because they actually use 3 motors per leg.
Yeah.
A lot of robot spiders that people build.
This is kind of their flagship right now. It's just being delivered, so I got mine just before Halloween in the first run.
It's amazing that they announced it as basically a prototype.
Yeah.
And said, you know, if you want to get in on this, we can deliver it to you, like you said, by Halloween, but it's all 3D printed parts.
It's all 3D printed parts, so the entire thing weighs 300 grams.
Hey, it's Norm from Tested. Welcome to another how-to project with Frank Ippolito, brought to you by Tested Premium members. Check out our memberships. That's what allows us to make these videos, show you how to do cool things. If you've watched this series before, we've done a few projects with Frank already. We created an easy, like, one-sided mold for our 3D printed objects to recreate those. We recreated my hand using an alginate mold. And today we want to take it one step further, a little more complex. We're doing a two-sided mold.
Two-part mold.
Two-part mold. So why would someone need to make a two-part mold?
If you have something that you can't just glue down to the table and dump rubber on, you need to have both sides of it. And maybe you want to have it so that it opens up so the piece demolds easier if there's like little undercuts or complicated parts that you can't just yank it straight out.
So if someone's a prop maker, for example, they make a space pistol or an elaborate prop that doesn't have a flat bottom edge.
Or if you wanted to make like a hammer or a wrench that was made out of rubber, if you want it, you know, for a prop, like a stunt prop.
Stunt casting, like a rubber prop. That's used in movies all the time. Well, we're going to recreate a prop today that I think is really cool. We're at Adam's shop, obviously, and Adam's allowed us to recreate something he made himself. It's not a space pistol, it's a space sword. It's a lightsaber. It's a lightsaber.
Did you wear this shirt on purpose today?
Of happy coincidences all around. This is Luke's lightsaber from, I believe, Return of the Jedi, and what Adam told me was he made this himself based on references from a 1995 Star Wars prop tour exhibit in San Francisco. He actually, that was right before the prequels came out, and he went to this exhibit. George Lucas donated all these props to it. He took a ton of photos, and this is one of his, I guess, the lightsaber he made back then when he was at ILM. Is this the right kind of thing that we want to create a two-part mold
Yeah,
from?
if we were to just glue it down and dump rubber on here, it wouldn't come out of the castings really good because all these little undercuts and all these little ridges. So
Right.
it's best if you want to make a two-part mold on this.
All right, so I presume like the other molds, a one-part mold, it's going to be some type of silicone, a molding material, and then you also want to create a shell for it. So what's the first step?
First step is we are going to clay this up so that we're only going to pour rubber on the first half.
Ah, okay.
So what we'll do is we'll take a piece of foam core, and I've decided that I want to put this on one side of the mold, so that way I'm not making a seam line across this. This will just come straight out the top.
Right. Whereas in a one-part mold, you don't have a seam line, unless you cut the mold open, because it's the flat base is where you tear it out, we're going to get a seam line.
Yeah, once you start getting into two-part molds, you have to think about how it's going to demold, where you're going to pour the resin in. Like we're going to pour the resin in this flat bottom area, which is really easy. You know, how the resin's going to flow and where it's going to go into. Like obviously pouring it from this end is going to be pretty easy because we could just kind of roll it around and get rid of air bubbles. And then like
it's been a long day. It's been a long day without you, my friend, and I tell you all about it when I see